Hello and welcome to the series of videos on logistic regression. Uh, in the last video, where we started summarizing the what means the different tips which happens in case of logistic regression. So let us proceed from there. So as we discussed that there is a data set, and the data set has uh, two broadly two parts. One is the set of independent variables that we say as capital X. Another one is the target variable that we denote as small y. And we have, let us say, m number of m number of observation, means m number of rows here. So what we do, as it's a supervised learning process, so we split the data. We take the independent variable x and the dependent variable y separately. So we take x, and now the main target is to find the value of theta, the value of parameter for the logistic regression, which can predict the right value of y as 0 or 1. And we do not know exact value of the theta. So what we do, that we randomly initialize the value of theta. So let us assume that we initialize the value as theta 0. So that theta 0 gets converted into theta. And then the very first step what we do, if you remember the steps what we discussed, that first thing is that we multiply the theta with x as we simply do in case of linear regression, and we calculate z. So z is equal to theta dot x, it's a dot product. The value of z is going to lie between minus infinity to plus infinity, and as our target variable is between 0 and 1, so we transform the z between 0 and 1, means the z is currently between minus infinity to plus infinity. That will be transformed in such a way that it will lie between 0 and 1. And to do that, we use the sigmoid function. So all this we have discussed earlier in the previous videos. So what is the sigmoid function says? The sigmoid function says that probability of y is equal to 1 given x parameterized by theta is equal to 1 plus the particular mathematical formulation what I am showing here in the box right now. So by this transformation, it will if we feed a value of x, it will take the value of theta and it will calculate the value of probability of y is equal to 1. So we have p predicted, we have actual target variable, that is y. So we compare these two, how closely the theta is able to predict the target variable, and this comparison we do by using the loss function. That comparison tells us, if comparison say if p is very close to if the probability what theta gives, the probability of y being 1 or 0 is close to the actual target value of the y, either 0 or 1, then the loss should be minimum. So by the comparison of the actual value y and the predicted value p is done by calculating the cost function. The cost function is nothing else but aggregation of the losses on all the observations. So we have here m number of observation. So the cost of the model given theta 0 is calculated like this. Okay. Once we calculate the cost, we check, is this cost minimum? But how do we know it's minimum? That's another question which we need to answer, which we are going to discuss in the coming slide. But just for assume that we know somehow that is it the minimum cost or not. If it is the minimum cost, theta 0 is the right value for the prediction model. But if it is not minimum, then we have to adjust the value on theta in such a way that the cost function's value should get or should tend towards minimum value step by step. But how do, so in that case we have to recalculate the value of theta. And how do we do that? That calculation is done by two things, two parameters. One, the existing cost, C theta, at the value of theta. And second, we give a learning rate. Again, it's another parameter which we are going to discuss. It's another parameter for the learning model which we will discuss in the coming discussions. So by the existing cost of the model and the learning rate, by referring to these two, we calculate new value of theta, and that value of theta is populated into theta, and again the same thing happens. With the new theta we calculate the value of z, with the new z we calculate the value of probability, then we compare the value of the probability with y, we calculate the cost function, we verify whether the cost is minimum or not. If it is minimum, the current value of theta is the right value for the predictive model. If it is not minimum, then based on the learning rate what we give, we calculate the new theta, and this cycle keeps on going on till we get the minimum value of the cost function. In another word, till we minimize the loss of the predictive model. So I hope this complete process is clear. Now let me just quickly summarize. So what are we get? What is the input for this model? Input for this model is x and y, the independent variable and the dependent variable. And the parameter for this model is theta 0. Theta 0 is the random initialization of the parameter of the model, and another parameter for the learning for the predictive model is L, which is called as learning rate. So to summarize, input for the model is the independent variable and the respective dependent variable. Parameter for the predictive model learning is initial value of the theta and then learning rate, and output of the model will be the theta which will minimize the cost of the predictive model on the input of the observations. So that's what in summary the logistic regression. This is how the logistic regression works in summary. And we talked many terms such as the initialization of theta, the cost function, minimum value of cost for function, learning rate. All this we are going to discuss in the coming video. So thanks a lot for watching. Please follow my next video in the series of logistic regression. Thank you.